Hello ladies and gentlemen, and welcome to another BIM video. How is BIM used in the construction industry? This video will explore the various dimensions of BIM and how industry professionals incorporate it in their project deliveries. The learning outcomes for this video, but hopefully by the end of the video you guys will understand what the dimensions of BIM are, the BIM process in projects, and the uses of BIM in the industry. The uses of BIM in the industry can be categorized based on how BIM is utilized. These uses will be related to the type of data that needs to be either generated or linked to your project. As such, we have what is referred to as the dimensions of BIM. Now, broadly speaking, and as of now, there are 7 dimensions of BIM. So these are the 7 main dimensions that people usually refer to. Each of these dimensions, they require a different set of data to be linked, a different modeling technique, a different application in the life cycle of the project. Remember that BIM can be used for both building and infrastructure projects. Now, the easiest dimension of BIM to comprehend is actually the 3D BIM. So that's the first dimension. Now, 3D BIM can be thought of as the initial model that you generate in a BIM platform, such as Revit, Bentley, or ArchiCAD. You should note that 3D BIM does not only refer to the 3D drawings of the construction project, as this is a common misconception in the industry, where people think of BIM as merely a visualization tool. It is not just a visualization tool. 3D BIM incorporates geometric information about the project. So when I say geometric information, I mean information about the size and the shape of, for instance, your beams, your columns, the footings in the building, and how all of these objects are linked together. You also have unique IDs for each instance of the objects that are used in the project. So each individual member in the project has its own unique ID. That's of course in addition to the material information, such as thermal properties, acoustic properties of the materials that make up these objects. You also have the unit costs and supplier information, just to name a few. This is of course in addition to your architectural, structural, and construction drawings. Now, 3D BIM can be thought of as basically a database of the project. So that's for 3D BIM. Let's move on to 4D BIM. Now, 4D BIM is where things get interesting, because it is in this dimension where you start incorporating additional data sets, namely a timeline to your digital model. This is often in the form of a construction schedule. So once you do that, you can simulate the progression of the construction activities. So you can monitor the process of the construction as it happens on site. You can visually see how the construction activities take place, what are some of the safety hazards that you need to plan for at the different parts of the project, and also you can conduct what we refer to as a clash detection. So you'd assess whether there are clashes between, say, your mechanical and your electrical components in the project. So that was for 4D BIM. With 5D BIM, you integrate an additional data set, and that's namely the cost data. And then you use that for cost estimation in your project. And in 6D BIM, it's another separate use where now you utilize the model in order to conduct analyses such as an environmental analysis. Some people also consider a structural analysis as part of this dimension. And there are people that also consider a 6D BIM as facility management. However, I personally prefer to keep 6D BIM for environmental analysis. And that's what I will be doing throughout my BIM videos. So some examples of environmental analyses that are included in 6D BIM, you have your daylight analysis, and that's important for the selection and the design of windows and internal lighting in your building. The energy analysis that's associated with the heating, the ventilation and the cooling system. So when you want to decide on the most appropriate HVAC system to adopt, you'd run an energy analysis to see what the results are like. And then finally we have 7D BIM, and that incorporates data sets that are related to the operation of the project. There's also some research out there that adds an 8th dimension, and that's the dimension that's associated with planning for safety during construction. We will only stick to the 7th dimension, but you have to be aware that in the future it's very likely that these dimensions will expand further as people in the industry figure out other ways of utilizing BIM. Okay, so how does the construction industry use BIM? That's a very important question. And for us to understand it, we first have to know that this depends on the location or the country that we're considering. So the level of implementation of BIM, let's say in Scandinavian countries, is different to how we implement it here in Australia. And that's because there are differences in regulations and differences in standards. But the most common application of BIM anywhere in the world is for communication purposes. So when you want to communicate your designs, you can utilize BIM. It has powerful capabilities when it comes to visualization. So a lot of companies like to use it in order to convey designs in a visual way for their clients. This, however, is only a small part of what can be achieved with BIM. BIM can actually be used to simulate and analyze any sort of risk associated with the project. Specifically, if you look at the 4D BIM dimension that we talked about in the previous slide. Some organizations, they use it for training purposes, specifically for the safe operation of machinery on site. And you also have some consultants that may use it to simulate the spatio-temporal value of a project across the life cycle. So you can think of this as some sort of a cost-benefit analysis, and they use BIM in order to conduct that. Likewise, policymakers can utilize BIM to assess the social value of the project to society. So when I say social value of a project, I mean assessing how many jobs that project will create, how much people will that project attract to a specific region or suburb. And then finally, a common application here in Australia is its use for automated cost estimation. Let's look now at the process involved when BIM is used in construction projects. Now the process, I sort of summarized it for you guys, as you can see in the figure in front of you. It is important to realize that the main reason why we use BIM on our construction projects is to enhance the decision-making aspect. So we want to make better decisions at various stages of the project. The process would have to start with a 3D model. If you don't have a 3D model, you can't move on to the other dimensions of BIM. You need to construct the 3D model in order to perform the set of analyses that we talked about in the previous slide. And these analyses then represent going through all the dimensions of BIM as discussed previously. The second step after you get your 3D model, after you generate it, involves generating your scenarios. So I'm talking here about the conditions and the requirements that are associated with the model. You can look at it from various perspectives. Let me give an example just to make it a bit clearer. What are, for instance, the materials that you need to use, and how will they be delivered? What if the materials don't arrive on time? Do you have any other alternatives? So these alternatives would then form part of the scenarios. What are the rates of the workers that you use to complete the specific activities involved in your construction project? What happens if these rates change? What happens to your cost estimation? And what happens if you can't find skilled workers to perform the activities? How will that impact your construction schedule? So deciding on an appropriate sort of set of scenarios involves you asking these questions. Another important thing that's important as well in this step is considering the most appropriate construction method. So for example, you can adopt cast in situ or precast as a construction method for your project. And in order to determine which is the most suitable for your case, you would need to conduct an analysis on such a scenario. So these are just some of the aspects that you need to think about when planning the scenarios for your project. For each scenario, you will need to incorporate a different set of data into your 3D model. If you're considering, let's say, material delivery as a scenario, then you need to incorporate data about the suppliers, the average delivery times, the cost, etc. These have to be linked to the individual objects that you have in your 3D model. So once you have your scenarios established, you can start simulating the project progression, and you can do that through 4D BIM. And then next you analyze and you evaluate the results from the simulation. You can make changes to the data input for the scenarios in step 2 of the process, and then you can rerun the simulation based on decisions that you make. Now the final step in this process is then coming up with a solution, so the decision that you're after for the project, and that's the whole purpose of going through this procedure with BIM. Let's look at an example just to demonstrate how this process works. Suppose that you had a project, a construction project that involved constructing a residential tower in the CBD. And of course you're aware that due to its location in the CBD, there are going to be issues with access to site. So the first step would involve you coming up with a 3D model of that residential building. And you do that on any BIM platform of your choice. The second step will then be implementing the scenario based on the decisions that you need to make. So for instance, how will traffic go in and out of the site? Where would you access, where would you place your access gates? And how would then this impact, so the locations of these gates, how would they impact the pouring activity of concrete? So that's all part of the second step in that framework that you see in front of you. And then the third step of the framework is where you run the simulation in 4D BIM based on the scenario that you just identified in the previous step. The fourth step is where you analyze all the factors related to site access based on the results and observations that you got from the simulation. And then here you can make changes to the location of the gate, for instance, and then that would sort of alter the access to the site. You can rerun the model again and then come up with various other decisions. So at the end, when you have this set of scenarios, you can make a choice on the most suitable solution for your project. In this next station of the video, I want to be looking at the BIM projects around the world. So what are some real-life projects that have been delivered using BIM? Now, I'll present to you 3 examples of real-life projects where BIM was utilized in the project delivery. These projects were chosen as I was either directly involved in them or I have visited them personally. We start by looking at a project that is close to home, and that is the Lady Cilento Children's Hospital in South Brisbane, Queensland, in Australia. The project had over 1,700 drawings, 2,900 layout sheets, so a tremendous amount of information that had to be organized and had to be shared between the different participants in the project. So it made sense for the team involved to use BIM in order to enable all the stakeholders to access and update drawings on the go. The use of BIM on that project enabled the construction team to quickly access information whenever required, rather than having to wait for an email from the person that they were requesting information from. And the BIM platform that was specifically used in this project was Revit. Let's now move on to Europe, specifically Helsinki. The Campy Center is considered to be one of the largest single urban construction sites in Finland. It was a project that involved the construction of transportation terminals for trains and buses. You had a shopping center, you had a commercial space, and you had a residential space as well. So this was all part of the project. The project's value was roughly around 500 million euros, and it covered an area of over 37,000 square meters. So there were over 800 subcontractors involved, which is a very huge number of subcontractors to be involved in any project. And so to allow for a smooth coordination process between all the participants in the project, BIM was adopted. Now the project ended up being delivered 6 months ahead of schedule, and that is an achievement in itself. Finally, we move to the Middle East, specifically the Opera House of Kuwait. This was a $775 million US project. Its size was roughly 214,000 meters squared. Revit was used to construct the 10,000 different geometrical structure forms, as can be seen from the facade of the building in the images in front of you. And that project in itself, Revit helped the various architects and the engineers that were involved in terms of coordination. I do hope that you guys enjoyed this video. If you did, make sure you hit the like button. Do check out my other BIM videos, and I see you all soon.